Let's call them carboxyl. Carboxyl. You'll see that in the form of carboxylic acid. But they call the group a carboxyl. So, simple one diamond. Got a double bonded O with an OH. That's the carboxylic acid single. So this common name I know as a fact is formic acid, where there's one carbon. Formic acid, or it'd be called methanoic acid, also methanoic. So there's a common name that the labs call it. If you ordered that up from a chemical company, they call it formic acid. Your chemistry teacher will make you be knowing it as methanoic acid. Just one carbon, though. That's the key to the whole deal there. So we take our green crayon to color it in. You got one OH and a double bonded O. Remember I told you before, when that isn't protonated, those two are the same carbons. So when you draw those considering the electrons, we have to draw a little different because those oxygens are indistinguishable. They're in the same predicament with the carbon than the other ones. So there you go, one carbon. So the chemical formula for that, you'd write it HCO2 or HCOOH more correctly, would show it's a carboxylic acid. Now, let's take two diamonds and see what happens. 1, 2. Got the same side group, so just double the O. Make that an O with a dot in the middle. And this is a methyl group out there. That's all there is to it. Color it in. Like it's colored on the inside because it's got both bonds to the carbon. We've got two carbons there. So that's going to be called an eth. Meth was 1. 2 is eth. So here's ethanoic acid. Just has two carbons with a carboxylic acid on the end. That's all there is to it. So color it in. One carbon with 3 H's. That's called a methyl side group. And this you'd call the carboxyl. The carboxyl. Take that proton, carboxylate. So, since we're so daring, let's try one more with 3 diamonds and see what happens. Now, carboxylic acid, when it's bound to a carbon, always has to be on the end. Remember with the ketone thing the carbonyl one? You got a double bonded O, but it can be in the middle. That's a real ketone. When it's on the outside, they call it an aldehyde. But there's still carbonyl is the name. Carboxylic acid has to be on the end. So the ethanoic formula, ethanoic acid, is C2H3 OOH. That's not how it's written. It's probably written H3COOH 2. No, I can't do that either. It's probably 1C, so it gets confusing. There's many different ways you can write it. But if you stick with one, as long as you got them all covered in there, I would write it. I tend to keep the COOHs together. So I'd write that H3C. Boy, I'm really rusty on this. There's a lot of different ways you can write it. So with three of them anyway, you got 1, 2, 3. It's going to be propyl for the 3 carbons. Propyl. And then it's a carboxylic. So propanoic acid, I bet is what that is called. Boy, how would you write that? COOH for the end. You still got 2 more carbons. H5. Boy, kids, I sympathize with you getting tested on this, because what's important is how it looks. That's all I focus on. So since we ran out of space, we'll draw the carboxylate part out here. And then these are just saturated in this case. So just dot, dot, dot. 1, 2, 3. So see, there's 5 H's out there. The 1 H is with the O. So that's why when you're writing it, try and keep it together. We can color in our greens here. We're done with those. And the carbon's done. Those are totally saturated. So just color them in. 1, 2, 3. Kids, this is as tough as it gets. When you're doing carboxylic acids, but see, the diamond structure makes this so much easier. This is how the book has it. See, I mean, that's just boring. Get that carbonyl, simple OH. I think our ways are more colorful. Ideally, what we want is a 3-dimensional structure. Okay, now here what we're going to do is with a blue, and you got a side group out here. It's called the amino group. So as that's coming off to the side, it's just our triangle. Remember the triangle? It's for N, nitrogen. 2 dots. Now, if you had one of these, that would be ammonia. Oh, God, I'm spelling ammonia wrong. You believe it? Oh, boy, it's getting late in the day. Is there 2 M's in ammonia? Two M's in ammonia. Gosh. 1, 2, 3. That's all there is to the amino group. Take your blue crayon, color it on in there. Now, to a real chemist, what you want to remember is there's a way that this can get a 4th bond to it. So you've got 1H, 2H, 3H, but it'll actually get a little plus charge in there and hold a 4th H by this electron pair in here. So the way we draw this, it's kind of like he's doing a little mind meld to hold that. So that's your alien. Ammonia is NH3. This is an NH4 with a plus on it. And this actually happens. If you get in a situation where there's a lot of protons around, that lone pair will end up picking one up. So that's the amino side group.